Right, let's have a look at, again, finding the x when it's the exponent. Now, the videos we just did, this is fairly straightforward to work out. I mean, you can see it's x equals 2, because 5 squared equals 25. Again, if you want to do it as the previous videos and write them as the same base, that's what it would be. Again, same base, so that's why x equals 2. But can you see that x is 2, just because 5 squared is 25, okay? Now, I cannot do this then. Can't do that. I have no idea what to put here to make 30, okay? I can do things like 5 to the power 1 is 5. 5 to the power 2 is 25. 5 to the power 3 is 125. So all these numbers are fine. Any other number is going to cause real problems, okay? Like the 30. So what do I do? Well, here's what you do. If you're trying to find the unknown exponent, just like here, okay, and this is what I get my students to chant in class, you log both sides. And you can use log or you can use ln. It's entirely up to you, okay? So I am actually going to just do this question here, okay? Okay, if I want to know the x is... Now I know it's going to be a bit bigger than 2. It's going to be a bit bigger than 2, remember, because 5 to the x equals 25. Well, that was x equals 2. So if it's going to be a bit bigger, it's going to be a bit bigger than 2. I'm going to log both sides. Log both sides. I've just written the word log in front of both sides. And the reason is remember this, you can bring the exponent to the front. So x log 5 equals log 30. Okay? So if we now divide by the number next to the letter, these logs, they're just numbers if you put in your calculator. Log 5, divide by the number next to the letter, okay? Then x equals that. And you would just put it on your calculator. Don't make a mistake. Make sure, if you have to put parentheses, okay? So that is it. So I'm trying to think of... There's other ways to do it, like the change of base rule. But that is you just applying, and you can apply it to all of these, okay? If I actually do this one here, okay? So if I just do this one here, this is going to be, again, log both sides. Okay, so 3.3 to the x, log both sides, okay? This can come to the front. X log 3.3 equals log 45. Divide by the number next to the letter, which is log 3.3. Then that over here on the right-hand side, put in your calculator, will be the answer, okay? Now then, let's have a look at the harder ones. Some of you might see on the test questions, maybe harder homework questions, and that is question 40. Okay, so, again, I'm going to log both sides. So log of 6 to the x plus 6 equals log of 7 to the x. Okay, there, I just logged both sides. That means this can come to the front and this can come to the front. So again, x plus 6 is now at the front of the log 6 and the x is in front of the log 7, okay? Now then, there are different ways of doing this. I mean, me as a shortcut, if I just want a final answer, a number, I would probably change this. I'd actually put in my calculator. Log of 6 is 0 point something, not exactly sure. Log of 7 is also 0 point something. And I might want to just do it in terms of just numbers without logs. But how the books show you is let's do the distributive law here. So x times log 6 and 6 times by log 6 is me doing the distributive law. This on the right-hand side is still the same, okay? Now, I need to get to x by itself. I need to get to x equals. I can see there's an x here and an x over here. I need them on the same side, okay? I'm going to subtract this one. Actually, think about it. This is the smaller one because log 6 is smaller than log 7. I'm going to leave that there. So I'm going to subtract x log 6 from both sides, okay? So I'm going to have this. This is still here, 6 log 6. But now on the right is x log 7 minus x log 6, okay? There it is.